Okay, we start with my favorite subject this week, convection, thunderstorms. I like talking about them. But let's understand a little bit of what we're dealing with thunderstorm. Here's a perspective diagram of an idealized thermal. I don't know if any of you have flown over the deserts, but at low levels, you can get these thermals that develop. And I've seen glider pilots just get in them and just hang there for, it seems like days. What they are is an area of unstable air, hot, unstable air rising. When they rise, they bring in air from the outside into that column of air and creating these vortex rings as they shaped here. And if you were to fly your aircraft through there, you could just get into this circle around that upper rising air there and just stay right in that vortex and really get a heck of a nice ride out of the deal probably for your glider pilot. So there's all kind of cloud growth with convection and all, but the thunderstorms that you see are actually warmer than the air around them. What that means is the base of the cloud develops at the convective condensation level. So the air parcels that are rising there are all warmer than the surrounding air. As they rise, they reach saturation because they've cooled, but they're still warmer than the surrounding air. So when that happens, that's where the cloud forms. And now that they've reached saturation, remember they're going to cool at the moist adiabatic lapse rate. So they're even cooling slower than the surrounding air. So they're actually more unstable, usually in here, once they reach convective condensation levels. So they continue cooling until basically they reach a level where they're either equal to the outside air or actually get cooler, and then they start going back down. But one of the nice things, interesting things about stability is it accelerates the air. It doesn't just move it upwards. It actually increases its speed. So that's why in these very warm areas here in thunderstorms like this, you can get speeds upwards of over 100 miles per hour. So if you were flying into that, it would not be a good, pleasant ride, to say the least. So here is an example. You can have unstable air aloft, too. Say you have a cold front that's moved along, and you get this a lot of times in the Midwest, especially in the springtime, where you get these thunderstorms that develop. They're kind of high-based, more like 5 to 10,000 feet almost, but they develop in unstable air that's above a layer of stable air, the colder air that's down below it. And when they do that, they can still get quite tall, still actually give you some severe weather out of them. So, moving on here, there's lots of radar stuff here. I'm going to go into that in a little more depth when we get into, I have a whole bunch of radar images and stuff I'll show you. But let's just talk about these thunderstorms. Basic life cycle. All the air initially goes up. And you see some of these in Florida, especially with towering Q. And eventually some of it starts coming down in the downdraft area where the rain begins. Rain is out there. It's a cooling process. Evaporation is taking place. So this air is actually cooler than this air next to it. So you have cold air coming down to the ground, pushing out ahead of it. Notice this little bow outward here. Upward air is moving in here. Cool air is coming down right here. Well, eventually, what happens is this cool air goes all the way out here. You can see it here on either side. So you wind up not getting any warm air coming into this thunderstorm. So you use no warm air, no convection. So you wind up with the ending of the thunderstorm and basically all the air is sinking. Now, think about it though. If you were in a jet coming into here, you were going to land, you would have a bunch of air going up, maybe wind direction this way, and then you got into this downdraft where the wind direction is exactly the opposite way. Not a good thing if you're trying to land an aircraft. So those are the basic stages. Now, we get thunderstorms that get multiple cells. So you get more than one thunderstorm. And these multi-cell thunderstorms will have updrafts and downdrafts in them. And there'll be a cluster of storms that may form together. And then sometimes you get what they're called supercell thunderstorms. They have rotation in them. They may have a flanking line, like this says, and gust fronts that go out from them. But the gust front never gets very far out. They're long-lived. And they're usually out separate from a squall line. Every once in a while you see them in a squall line, but most of the time they're out separate from it. And there's your wall cloud here. A wall cloud is basically an area of rain-cooled air that sits down below the cloud surface where the downdraft has come down, but now there's a new updraft started right here that's pulling this air up. It cools it so that the clouds actually form below the main level of clouds. If you see that, you want to get away from there, basically. That's a good area for tornadoes to develop with time. And there's all kinds of stuff on tornadoes. Hail is also another part of this with thunderstorms. But let's just take a look at some thunderstorms right now. This is a multi-radar, multi-sensor. Radar is a unique tool. So we'll take a look at some radar images here with dual polarization and regular images. Regular radar sends out a horizontal pulse, just like this, receives, transmits, picks up on the moisture out there, and discovers what kind of images you might get, like water, precipitation, clouds, even some bugs get picked up in it. So if I were to go to wave and look at the current radar image that we have out there, you'll see lots and lots of areas of precipitation. Let's look in here a little bit closer, just at one. And this is basic reflectivity image. Now, if I wanted to look at velocity, we have a base velocity image. Now, Doppler radar says I can see it. Oh yeah, we're at 0. Your wind is perpendicular to that point. So it goes from green to red. So this wind is out of the southwest in this direction. Sometimes you see these change directions for height because you're picking up different height layers with the radar. All that is part of what you're seeing with getting you an image of thunderstorms. Oh yeah, radar can also do an estimate of rainfall. And here's their estimate with about 3/10 to 6/10 of an inch out in here near Jackson, Kentucky right now. Some lesser amounts further north. But I wanted to take you to dual pole because it is the future of radar right now. I said everything in right now was horizontal. Well, dual pole is out there, and it's vertical pulse as well. So what does that mean? That means you can get a diameter or a shape of particles. So with that, you can get some neat things called differential reflectivity. What that means is there's a change in the size of droplets or size of bugs or whatever you're looking at on the radar. A significant change. And it picks it up. For example, here is just base reflectivity, your normal view of a thunderstorm. And there's an area that really looks like it has some tremendous rainfall potential in it. But you don't know that that's just really, really heavy rain, maybe some strong wind gust in it, or does it have something else? Notice here where the change in size occurs. And you can really see it right in here, which would be this in this little part right here. That's where your biggest hail is actually occurring. So if you're a pilot, you want to avoid that hail. So, and just looking with this, you can actually pick up this multi-radar, multi-sensor picks up like lowest reflectivity. And remember, one of the things you're getting here, radar gives you a base reflectivity, and it also gives you a composite reflectivity. The composite is taking the maximum reflectivity at every angle that the radar is looking upwards and compositing it together. So you're seeing the worst case scenario here, which is probably good if you're a pilot. You can see a squall line down here. You can see the circulation of what's left of delta right here. You can see rain out ahead probably of a warm front moving north right here. And if you wanted to go move your area down into Florida right now, you can actually see some showers and all forming out over Nassau and that area and up into Florida itself. So with that, here's how one way is forecasting it. There's actually models that actually predict what's going to happen with radar. And they are a basic weather model, but this very high resolution is actually looking at about 1 kilometer. And it's forecasting how that rain is going to change, what's it going to look like on radar. And with that, you can actually pick out sometimes thunderstorms and other interesting things. But right now, you can see a little bit heavier rain forecast, back where we've already had some, and back towards Delta, there's some more of that as well. And here's a sector in Florida right now. You can see bubbly thunderstorms right along the coast here. I wanted to look right here. I would argue that there's a sea breeze developing right there, a local breeze that's pushing the clouds inland a little bit, keeping the coastline a little bit clearer. So if you happen to be at the beach in that part of Florida, then you might get a little bit more sunshine. So this is what I really wanted to talk about with this section. So we'll stop here for now.